convert as indicated. We're looking at 3.05 kilograms to grams. The conversion is within, all this is a mass conversion within the metric system, which is properly known as the Sistema Internacional, or SI, system of measurement. And there is a fast method to operating with common units within the metric system. And there's a little bit longer method which requires knowledge of equivalent measurements within the metric system. So I'm going to do this by two methods. Method one, we're going to arrive at the same answer just by two different methods. I'll do the easy way first. The easy way. For common units, the easy way. For common units of prefixes and such for the metric system. And that is, if we list out the common range, we have kilograms, hectograms, decagrams, and then here's like the main unit, grams. I'm just going to use it as a little g. These are the big units, 1,000, 100, or 10 grams. Then you have the base unit, which is 1 gram. Then we have, below that we have decigrams, centigrams, and milligrams. So these are the most common range of everyday prefixes from the metric system. There's a little mnemonic device so we can remember this order for people who don't use it every day. Is King Henry died while drinking chocolate milk. King Henry died while drinking chocolate milk. If you can remember that, then it makes conversions in this range very easy. Here's how. We write the unit. I'm going to show a hollow point, decimal point, where the original decimal number is showing in kilograms. Now let me change color, see if I can do this quickly. We're going from kilograms to grams. So if I'm starting on kilograms, look, I'm starting on kilograms and we're going to grams. I'm starting on kilograms and we're going to grams. If we use these prefix, this acronym KHD, the King Henry died while drinking chocolate milk, I start my cursor on the K and I start moving one hop at a time from K to G. And it ends up to go from kilograms to grams. We made 3 hops and we went to the right. I start on this decimal point and I go the same thing. 1, 2, 3 hops to the right, and we insert, if we have an empty hump, we insert a 0 over it. And now the units, when we went from kilograms to grams, we moved over 3 places to the right. The unit of measure on this now is grams. We've actually made the conversion. So that's the easy way. We're done. And the interpretation of this is that 3.05 kilograms is equal to 3,050 grams. And that's good enough to find our answer. 3,050, the correct response is C here. That's the easy way. The next method, method 2, and if the method 1 works for you, you do not need to continue listening any further to this video. This is the dimensional analysis method. This method works on all dimensional analysis. This method works on all unit conversions. And what we do is we have to know the relationship between 2 different units. It turns out that 1 kilogram is the same as 1,000 grams. So we start our conversion using method 2 by writing the original number, 3.05 kilograms. We're trying to make that become a certain number of grams. We just need to fill in this blank with the correct number. we're going to multiply by a conversion fraction. These are called unit fractions because we put the new unit up in the numerator. This is the new unit. And we copy the old unit where we're coming from down in the denominator. And then we use the number that's in front of kilograms, we put that next to kilograms. So that one belongs in the denominator. And we put the number that's next to grams in the definition. This is called the definition of how the two units equal each other. We put this number next to grams in the conversion fraction. So what ends up happening here, I'm going to go ahead and change my color to red so you can see the action steps that we take. We're going to create this first fraction, we're going to put it over 1. Between a number and its unit of measure, we consider the be times. The multiplication allows us, for any common factors like kilograms and kilograms, they're going to divide each other out. Anything divides into itself once. The only units left in this expression are grams, and that's the unit that we want to end in. So here we have 3.05. I'm going to use a hollow point again. 3.05. It's timesing a factor of 10 that's got 3 zeros in it. And this is a factor of 10 that is greater than 1, so we end up moving with multiply. We move the decimal point once for each zero to the right. 1, 2, 3. And we wind up needing to insert a missing zero over this empty hump. Here's where the decimal point ends, and we're allowed to now interpret this as our final answer. And that brings us, of course, to the same correct response. Both methods are excellent, but the easy way is the fastest way.